Hi, this video is on section 10.1. In chapter 10, we learn how to compare the mean of one distribution to the mean of another distribution. So inference on two means. The first thing we have to figure out is whether the two distributions that we're comparing are somehow really bound, or are they really two separate distributions? And I'll just kind of give you a general idea. So if we took a random sample of, 10 dorm rooms, and then we went into the dorm, and these would be just dorm rooms where there are 2 students in each room, say. So we go in and we take the sample of the 10 dorm rooms, and then we talk to or survey 2 different roommates. So the fact that roommate number 1 is in the survey, is in the study, completely determines whether or not roommate number 2 is in the study. Okay, so that case, those 2 samples of roommate 1 and roommate 2 depend on each other. So those are called dependent samples. And an example of independent samples is if we took a sample of size 10 from University A and a sample of size 10 from University B, and we're comparing some measure in the 2 universities, right? And so then the fact that somebody was in my sample from University A does not have any bearing as to whether or not one of the students in University B is included or not included in the study. So that would be two independent samples. So note, with the roommates, I did 1 random sampling, okay? And then in the case of the 2 universities, I actually did 2 random samplings, 1 from A and 1 from B. So if the study is designed in a way that requires 1 sample, and you're comparing means, then those samples must be dependent. And if you look at the setup of a study and you see that there were 2 random samplings, then those 2 samples are independent. All right, let's go over the notes, kind of just pretty much what I just said, but we'll just look at some definitions and all. So 2 samples are independent if the sample values selected from one population are not related or somehow paired or matched with the sample values selected from the other population. So that's the 2 universities I referred to. 2 samples are dependent if members or consist of matched pairs. If members of one sample can be used to determine the members of the other sample, all right? That's the roommate sampling situation. So sometimes also we can have, or very common in the paired or dependent samples, would be a pre and a post test situation. So you would get a test, and then you would get a treatment, and then you would get another test, right? So it could be anything from learning fractions to peripheral eye vision. So a researcher conducted an experiment to see if a specific eye exercise can improve peripheral vision. A random sample of 5 people were rated for peripheral vision on a scale of 1 to 20. Okay, so they were rated first, that's the before, and then they were prescribed eye exercises, and then they were rated again. So that's the after. Researcher wants to know if the after test scores are greater than the before test scores. Note here, how many times did we take a sample? Only once. 1 random sample of 5 people. That means that the 2 sets of measures must be paired. They must be dependent. And let's look here. Olfactory, sense of smell. A study is conducted comparing olfactory sensitivity in men and women. So 35 women are involved in the investigation. A sample of size 20 was taken from the population of males, and a sample of size 15 was taken of females. The data shown here, okay, reflects the sensitivity scores for the 35 patients, and by higher scores indicate more olfactory sensitivity, so easier to smell. Okay, and here what we have is for the males, there are 20 males, and that's their mean score, and that's their standard deviation score. Okay, here's the females. And we see here. So the researcher wants to know if the male scores are equal to the female, if the male scores are equal to, but what they really want to know is the mean olfactory sensitivity for men equal to the mean olfactory sensitivity for women. So note that a random sample occurred twice, and once for the population of males and once for the population of females. That makes this an independent sample. Okay, so we're just going to kind of look through a couple of these, a few of these descriptions and determine if they're independent or dependent. So a sample one is the weight in pounds of 26 newborn females and the weight in pounds of 26 newborn males, okay? So that's two samples that were taken, even though they have the same sample size, right? You still have to think about it, right? So it's not, because in this case, there was actually two samplings. So this is the fact that one of the female babies was in the study did not determine whether one of the male babies was in or out of the study. Okay, and the scores of 16 students who took the ACTs and the scores of 16 students who took the SATs. Okay, so again, there's no pairing or determination from sample one to sample two. And it looks like there were two sets of samples, so this is also independent. All right. So the Worcester State University administration wants to determine if our math professors are older than our biology professors. A sample of size 7 math professors is taken, and a sample of size 9 biology professors is taken, and their ages are recorded. Okay, again, right? There's an independence because how the determination of whether or not a biology professor was in the sample didn't come from who was in the math sample, right? So these are also independent. And a sample of 10 MA 150 students are given a pre-test on chapter 10. Then after class, they are given a post-test. So this is a single sample, okay? That makes this dependent or paired. Okay, all right. Okay, so that's pretty much the definition of dependent and independent. And where we're going to go in this in this chapter is that we're only going to be working in the situation where we're comparing independent samples. I just need you to know how to determine if a sample is dependent or independent. So when you do use that tool, you use it only on the appropriate kind of data setup. All right, so I'll see you in the next video.